This is section 3.2 from MathLinks 8 on Pythagorean relationship, exploring the Pythagorean relationship. Question number 1 says, describe using words and symbols the relationship among the areas of the three squares shown. Well, if we think about what Pythagoras said, these two black lines, he said that those two black lines which make up the 90-degree angle, they're called legs. And usually, in his theorem, he called them leg A and leg B. And the third side of the right triangle, which is across from those, he called C, and it's called the hypotenuse. So in words and symbols, you could first say that 64 plus 225 is equal to 289. Or more specifically, if I reverse them, I should go A here and B here now that I did that. A squared, or the area of this square here, plus B, this is B now, B squared, which is 225, equals this number squared, which is C squared. In the second question, it says a triangle has a side lengths of 7, 11, and 15. Explain how you can determine whether or not it's a right triangle. So if you drew the triangle first and put a question mark here to determine whether it's right, since there are three sides, 7, 11, and 15, we know that the longest side of a right triangle is called the hypotenuse. We'll put 15 there. And it does not matter whether 15 goes there, or 11 goes there, or 7 goes there. It doesn't matter. So we're just going to put 11 in there. It says, how could you determine? Well, the first thing you would have to do is attach squares. This is one method to each of them, and see if the area of each square works. So this would be, if the side length is 7, then the area of this square would be 49. If the side length of this is 11, then its area will be 121. And if the side length of this is 15, then its area would be 15 squared, which is 225. And if 49 plus 121 equals 225, then it is a right triangle. But because it doesn't, we know that this is not a right angle. Right? We know it's not a right triangle because the area of the two squares attached to what would be the legs do not equal the area of the square attached to the hypotenuse. Question 3, for the triangle shown, Kendra wrote the Pythagorean relationship as r squared is equal to q squared plus p squared. Is she correct? The answer is no, she's not correct. And the reason why is this and this side here r and this side here q are the two legs. So in this particular letters, r squared plus q squared will equal p squared, not r squared is equal to the sum of these two. Now that's a very important one. It's this area plus this area equals this area. And finally, question number 4, where we started, I believe, in our sheet. What are the areas of the three squares shown? Well, E equals 30 millimeters. And what you must assume is that E represents not the area, but the side length. How do we know that? How do we know that's a side length and not an area? Ryan, what would you say? Oh, Dean. Because it doesn't say millimeters squared, so that tells us that that is not an area measurement, but rather a side length measurement. So because the side length is 30, then 30 squared will be its area. And if I took a calculator, 30 squared is 900. Another easier way to do that is, well, 30 times 30. Just take your 3 times 3 to get 9 and add 2 zeros onto it. That's an easier way to square numbers that end in 0. For 40 squared, this area here would be 4 times 4 is 16, plus 2 zeros. This is 900 again. And 50 times 50, well, 5 times 5 is 25, plus 2 zeros. So 40 squared equals 1600, and 50 squared equals 2500. A right triangle has side lengths of 40, 75, and 85. So first thing I'm going to do is sketch the rectangle. It says it's right, so I'll put my symbol in there. Since I'll put 85 there. And my other two, it doesn't matter. I'll just put 40 and 75 here and here. I'll attach squares to each of these sides like the instructions say. And inside there, I will put the area of each of the three squares. Well, 40 times 40 is 4 times 4 is 16 plus 2 zeros. 75 times 75 is a tricky one. I don't know that off the top of my head. So I'll take 75 and I'll square it. Or if you don't have a square button, you can just multiply it by itself. And it's 5625. And if this is true and if it's a right triangle, do I know what 85 times 85 is without using multiplication? Without doing 85 squared or 85 times 85, how can I figure out what 85 times 85 is? Yeah, just take your 5625 and add your 1600 to it. And that should be what 85 squared is. So 5, 2, 12, carry it 7. 7225 should be your answer. Grab your calculator just to double check. 85 squared is 7225. Question 6 says write an addition statement using the area of these triangles. So 25 plus 144 equals 169. What is the length of each side? Well, since this area is 25, its side length would be 5. Since this area is 144, its side length will be 12. And since this area is 169, the square root of 169 is 13. So a 5, 12, 13 is the whole number Pythagorean side length. Question 7, let's skip that one, it's redundant. Question 8, is the triangle shown a right triangle? Explain your reasoning. Well, here we have the areas given, and this is the apparent maybe 90-degree angle. And since 40 plus 20 does not equal 50, we can say no, it is not a right triangle. If it was, this would have to have an area of 60 square centimeters. Question 9 says calculate the areas of the three squares. So since the side length is 3, its area is 9. Since the side length is 2, its area is 4. And since the side length is 4, its area is 16. And because 4 plus 9 does not equal 16, this is not a right triangle. Skip 10, redundant. Skip 11, redundant. Question 12, the area would be 52 because 20 plus 32 is 52. This is a tricky one. Leg, hypotenuse. So 576 plus 100 means this is 676. Some people might have put 476 down. This plus this equals this, which means 25 plus what is 90? The answer is 65. And finally, 12 plus 12 equals 24. Question 13, a small triangular flower bed has a square stepping stone on each of its sides. The flower bed, is the flower bed in the shape of a right triangle? Explain your reasoning. Well, as always, 4,800 plus 4,800 does not equal 9,800, and therefore this is not a right angle. Question 19 says construction workers have begun to dig a hole. So this is the hole here. So they started digging the hole, and this is how far they went down. They went down this far, 6 meters. They measured the diagonal shown to be 9.5 meters. So 9.5 meters here. Is it a right triangle? Well, if I redraw, I'm going to invert it here. So this is 8, and I'm going to put it down here. This is 6, and I'm going to put it here. And I'm going to put the, 6. I'm going to put the diagonal of 9.5 here. So basically just took this picture and flipped it upside down. Okay. This would be 64, excuse me. This would be 36. And 64 plus 36 is 100, but 9.5 squared. 9.5 squared does not equal 100, which it should be, right? Because 36 plus 64 is 100. So therefore, this is not a 90-degree angle. I think I skipped 16. Question 17. What is the area of the square that can be drawn on the side of C? So this one here, 21 squared. Grab my calculator. 21 squared is 441. 28 squared would be the area of this one, which is 784. So 441 plus 784, 441 plus 784 is 1,225. And if that's the area of the square that's drawn on here, then how would I determine the length, Ryan, of C if I know the area? How do I do it? Square root. So take 1225 and use the square root button. And it would tell you that C's length would be 35. If the square attached to it is 1,225 units squared, then the side length would be the square root of that, or 35.